Okay, so good morning once again, everyone. And I think this will be our last meeting for statistics. No? So, and the topic for today is about a t-test. No? T-test, of course, t-test is a statistical test that is used to compare the means of two groups. No? It is often used in hypothesis testing to determine whether a process or treatment actually has an effect on the population of interest, or whether two groups of different from one another. So you may know whether the mean petal length or iris flowers differs according to their species. No, so you or species. No, you find two different species of irises growing in a garden and measures 25 petals of each species. No, you can test the difference between these two groups using a t-test. So, of course, the null hypothesis is that the true difference between this group means is zero. And the alternative hypothesis, or HA, is that the true difference is different from zero. So under t-test, of course, we have the type of t-test, of course, performing a t-test, interpreting t-test result, and presenting the result of a t-test with some additional discussions related to one or two or paired t-test. Okay, so to give us more details about the topic, let us all welcome our presenter.
Good day. My topic is all about T-test, independent and paired, and Z-test. What is a hypothesis? A hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variables to some dependent variables. A hypothesis states that what we are looking for and it is a proportion which can be put to a test determine its validity. Example, students who receive counseling will show a greater increase in creativity than students not receiving a counseling. Here are the characteristics of a hypothesis. It is clear and precise, capable of being tested, stated relationship between variables, limited in scope and must be specific, stated as far as possible in most simple terms so that the same is easily understood by all concerned. But one must remember that the simplicity of hypothesis has nothing to do with its significance. Consistent with most known facts, responsive to testing in reasonable time, and one can spend a lifetime collecting data to test it, and explain what it claims to explain, and it should have empirical reference. Null hypothesis, it is an assertion that we hold as true unless we have sufficient statistical evidence to conclude otherwise. The null hypothesis is denoted by H subscript 0 or H0. If the population mean is equal to hypothesized mean, then null hypothesis can be written as H subscript 0 is to mean is equals to mean subscript 0. On the other hand, alternative hypothesis is negation of null hypothesis and is denoted by H sub A. If null is given as H null is to mean is equals to mean sub 0, then alternative hypothesis can be written as what we see below. We will go to the level of significance and confidence. Significance means the percentage risk to reject a null hypothesis when it is true and is denoted by A, generally taken as 1%, 5%, or 10%. 1 minus 8 is the confidence interval in which the null hypothesis will exist when it is true. Let's go now to the risk of rejecting a null hypothesis when it is true. So we will have an example for plotting. For designation, we can go to the supercritical. For the is 0.01 or 0.1% and the confidence level 0.999 or 99.9%. So we can see this description is more than 100 billion pesos or large loss of life due to flooding. In the critical designation, we can go the risk of 0.01 or 1% and a confidence level of 0.99 or 99%, which is less than 100 billion. Or we can see that a few lives was lost. For the important naman, risk of 0.05 or 5%, confidence level of 0.925 or 95%, which we can describe as less than 100,000 pesos was lost, and no lives lost, injuries lamang, so injuries occurred. With the moderate designation, we can go to the risk of 0.10 or 10% and a confidence level of 0.9, 90 or 90. And reject the null when type 1 error occurred or alpha error. When the null is false, the decision to accept the null is type 2 error or beta error, and reject the null is correct. Let's go to the two-tailed test at 5% significant level. Acceptance and rejection regions is case of a two-tailed test. So as you can see with the red lines, there are the rejection region or significance level are from left and right. Or you can see that 2.5% is the rejection uh, region. And the total acceptance region or confidence level is 95%. When left-tailed test or 5% the significance level was used, so acceptance and rejection region in case of a left-tailed test, as you can see in the left side of the red lines, so rejection region is 5% or the significance level, but the total acceptance or the confidence level is at 95%. While the right-tailed test at 5% level, the acceptance and rejection region in case of a right-tailed test. So as you can see on the graph, 5% rejection region or significance level with the red lines are on the right side, and the total acceptance region would be or the confidence level of 95%. After the discussion on hypothesis testing, we will go now to the hypothesis testing of means, which are t-test and z-test. So here, what is a t-test? So as we can say, a t-test is a type of inferential statistic used to determine if there is a significant difference between the means of two groups, which may be related in certain features. A t-test is used as hypothesis testing tool, which allows testing of an assumption applicable to a population. A t-test looks at the t-statistics, the t-distribution values, and the degrees of freedom to determine the statistical significance. To conduct a test with three or more means, one must use an analysis of variance. As I mentioned earlier, there are two types of t-test. First, we'll go to the paired t-test. A paired t-test, also known as a dependent or correlated t-test, is a statistical test that compares the averages or means and standard deviation of two related groups to different to determine if there is significant difference between the two groups. So a significant difference occurs when the differences between groups are unlikely to be due to sampling error or chance. The groups can be related by being the same group of people, so the same item or being subjected to the same conditions. Paired t-tests are considered more powerful than unpaired t-tests because using the same participants or item eliminates variation between samples that could be caused by anything other than what's being tested. So what are the assumptions of a paired t-test? So the dependent variable is normally distributed. The observations are sampled independently. The dependent variable is measured on an incremental level, such as ratios or intervals. The independent variables must consist of two related groups or matched pairs. When to use a paired t-test? Paired t-tests are used when the same item or group is tested twice, which is known as a repeated measures t-test. Some examples of instances for which a paired t-test is appropriate include the before and after effect of a pharmaceutical treatment on the same group of people, body temperature using two different thermometers on the same group of participants, standardized test results of a group of students before and after a study prep course. The other type of t-test is unpaired t-test, also known as independent t-test. It is a statistical procedure that compares the averages or means of two independent or unrelated groups to determine if there is a significant difference between the two. So what are the assumptions of an unpaired t-test? So the dependent variable is normally distributed. Observations are sampled independently. Dependent variable is measured on an incremental level such as ratios or intervals. The variance of data is the same between groups, meaning that they have the same standard deviation, and the independent variables must consist of two independent groups. When to use an unpaired t-test? An unpaired t-test is used to compare the mean between two independent groups. You use an unpaired t-test when you are comparing two separate groups with equal variance. So of appropriate instances during which to use an unpaired t-test is research such as pharmaceutical study or other treatment plan where one half of the subjects are assigned to the treatment group and the other half of the subjects are randomly assigned to the control group. Research during which there are two independent groups, such as women and men, that examines whether the average bone density is significantly different between the two groups, and comparing the average commuting distance traveled by Pasig City and Marikina City residents using 1,000 randomly selected participants from each city. Paired versus unpaired t-tests. The key differences between a paired and unpaired t-test are summarized below. A paired t-test is designed to compare the means of the same group or item under two separate scenarios. An unpaired t-test compares the means of two independent or unrelated groups. In an unpaired t-test, the variance between groups is assumed to be equal. In a paired t-test, the variance is not assumed to be equal. Let's have a comparison of paired versus unpaired t-test using a table. In a paired t-test, it defines as statistical test used to determine if there is a significant difference between the means of two dependent samples. In unpaired t-test, it defines that a statistical test used to determine if there is a significant difference between the means of two independent samples. With regards to relationship between groups, in the paired t-test, there is a relationship between groups, while in unpaired t-test, there are none. In the assumption of equal variances between groups, in the paired t-test, there is no assumption that equal variance between groups, while in unpaired t-test, there is an assumption that equal variance between a group. Let's have an example situation of paired and unpaired t-test. So, insulin rate is measured on 30 patients before and after the medical treatment. Data are thus organized by pairs, or every patient is associated to two measurements. So an appropriate test to use here would be a paired two sample t-test. On the other hand, insulin rate is measured on 30 patients receiving a placebo and 30 other patients receiving the medical treatment. In this case, all of the measurements are independent. An appropriate test to use here would be an independent two sample test. After the discussion of hypothesis testing of means using t-test, we will go now to the hypothesis testing of means using z-test. So, what is a z-test? A z-test is a statistical test used to determine whether two population means are different when the variances are known and the sample size is large. The test statistic is assumed to have a normal distribution, and nuisance parameters such as standard deviation should be known in order for an accurate z-test to perform. It is better to understand what is z-test. So, the z-test is also a hypothesis test in which The Z statistic follows a normal distribution. The Z-test is best used for greater than 30 samples because, under the central limit theorem, as the number of samples gets larger, the samples are considered to be approximately normally distributed. When conducting a Z-test, the null and alternative hypothesis, alpha and z-score should be stated. Next, the test statistic should be calculated, and the results and conclusions stated. A z-statistics or a z-score is number representing how many standard deviations above or below the mean population a score derived from a z-test is. Example of tests that can be conducted as z-test include a one sample location test, a two sample location test, a paired difference test, and a maximum likelihood estimate. Z-tests are closely related to t-tests, but t-tests are best performed when experiment has a small sample size. Also, t-tests assume the standard deviation is unknown, while z-tests assume it is known. If the standard deviation of the population is unknown, the assumption of the sample variance equaling the population variance is made. As mentioned earlier, you will use a z-score or z-statistic. And what is a z-score or z-statistic? Z-score or z-statistic is a number representing how many standard deviations above or below the mean population the score derived from a z-test. Essentially, it is a numerical measurement that describes a value's relationship to the mean of a group of values. If a z-score is 0, it indicates that the data point's score is identical to the mean score. A z-score of 1.0 would indicate a value that is one standard deviation from the mean. And z-score may be positive or negative, with a positive value indicating the score is above the mean and a negative score indicating it is below the mean. Let's differentiate z-test and t-test. Z-test is the statistical hypothesis which is used in order to determine that whether the two samples means calculated are different in case the standard deviation is available and sample is large, whereas in t-test, it is used in order to determine how averages of different data sets differs from each other in case standard deviation or the variance is unknown or not known. Z-test and t-test are two statistical methods that involve data analysis, which has applications in science, business, and many other disciplines. The t-test can be referred to as a univariate hypothesis test based on t statistic, wherein the mean or the average is known and the population variance or the standard deviation is approximated from the sample. On the other hand, z-test also a univariate test which is based on standard normal distribution. We will differentiate z-test and t-test using infographics. In the basic definition, z-test is a kind of hypothesis test which ascertains if the averages of the two datasets are different from each other when standard deviation or variance is given. In t-test, it can be referred to as a kind of parametric test that is applied to an identity, how the averages of two sets of data differ from each other when the standard deviation or variance is not given. In the population variance, in z-test, population variance or standard deviation is known, while in t-test, standard deviation is unknown. Using a sample size, when using t-test, you will use a large sample size, while in t-test, small sample size. What are the key assumptions? Using z-test, all data points are independent. A normal distribution for z with an average 0 and variance is equals to 1. While in t-test, the assumption is that all data points are not dependent and sample values are to be recorded and taken accurately based upon the type of distribution. So, using z-test based on normal distribution, while in t-test is it based on student t distribution. That would be my report. Thank you.